Good afternoon. Hoping this mic works still. So today I'm going to introduce Kali's string theory. I was thinking about this the other day, and it's just like another way of thinking about charge, especially charge, but just particles and this and that. Okay, so as you can see, I've got a bunch of strings and I've colored them blue and yellow. And the yellow represents negative charge, divergence, and this is convergence, blue charge, positive. And let me just say, fundamentally, it was one of Maxwell's. Something that comes out of Maxwell's equations is every divergence has a convergence. You might just only be looking at the curl sometimes and not the whole process, part of a process. But every divergence has a convergence. This is important. There's always a reconnection. So we're going to take one of these strings and let's just look at a string even, okay? So this is an electron. And you'd say, yeah, but that's only half of a string. And I would say, yeah, kind of exactly right. In more ways than one. And people are like, oh no, the spin is like, it doesn't mean that kind of spin. But if we allow this halfness to be, and anybody who's watched one of my videos on sidedness, and that I believe we exist on a single-sided surface with two regions. And the straddles, the electron is straddling the surface. Okay, it's only a half of a thing. To be a whole thing, you'd be a photon. And if you could have, this would be, I guess, oniums? It could be an electron, positron, onium, in a way. And what happens is you close it up and you have a photon. Or this could be a photon, I guess. But we close it up and now we have a photon. Right? And a photon is also how I see mass being created. Right? So we've closed the loop. We've made a reconnection. So there's a photon. Sorry, I only have black tape. There would be a photon. Right? So that would be a Higgs particle, let's say. And then to make a proton, we'd need another one of these. And you'd say, yeah, well, there's the mass, and there's the, then there's the positive by the mass there. Oh, yeah, and we have these yellow parts sticking out, the electron field sticking out. And you'd be like, oh, come on. It's like, yeah, but what we're going to do is we're going to do electron capture. We're going to throw a neutrino, which is curl, and curls it up, and we'll make this also into a mass particle. And we could say now we have a neutron. This would be a way of representing a neutron. Two rings, the Higgs, and then the extra layer of trapped photon around the Higgs. Okay, now that's one way of doing a neutron. And another way of doing a neutron would be, here, let's just make a loop in this. Because this is, it's a loop. So that represents a whole circle. And then also with ends sticking out. And then if we joined these ends together, we would have a neutron. Also, this would be another way of showing a neutron. This is what I think is the better way of doing it, because we never have, for every proton there is an electron, because for every positron there is an electron. And now we've got a neutron. Oh, do you know what's odd? Hey, that's the trefoil knot in the other In the non-trefoil, let me pull this apart. I need to twist something someplace. I'll turn this into a trefoil knot. It is a trefoil knot. I know it is. There it is. So that black part is actually, like the knot. So boop. It is a trefoil knot. But that would be as a way of thinking about reconnections. And we could even build up. It's like there's a neutron, so that's the basic particle. But let's get a longer string. Because how would a helium be? Helium would be, when you bust up a helium, what do you get? You get 2 deuteriums? Uh-oh. I'm going to have to do my studying. But this works for the helium, and this is all I was thinking about so far. But look at that, there's a neutron. And then the neutron decays, and it becomes some mass with some positive charge and some negative charge.